So this section is about the behavior of gases, which is Chapter 3, Section 3. And when you're figuring out the gases, we need to use measurements such as volume, temperature, and pressure. We have to know all three of those variables in order to understand how gases are going to work. So how are they all related? The pressure of a gas is the force of its outward push divided by the area of the walls of the container. So if you can think of this basketball here being a container and all of that gas that's inside of it, the amount of pressure is how hard is it pushing on those walls. Well, if I take that same amount of gas and put it in a larger ball, the pressure is not going to be as great, and because the container is bigger now. Also, if I were to put a hole in it, well, now the container is the entire room, so it won't have very high pressure, as shown here in this second picture. Temperature and volume. When the temperature of a gas is increased at a constant pressure, and it's important that you're talking about a constant pressure, its volume increases. So if I keep the pressure here and I increase the temperature, or I decrease the temperature here, lower temperature, it's going to take up less amount of space and have a smaller volume. If I leave the pressure up here, where this plunger is, and I increase the temperature, it's going to have a greater volume. It's going to end up spreading out. The molecules are going to end up spreading out. And when gas is heated, the particles move faster and collide more often with each other within the walls of their container. That should make more sense. As you heat up, right here, if we have something of low pressure here, we have higher pressure. As we heat it up, those molecules get moving around faster, get moving around more, and they have more collisions with the walls of the container and with themselves. So that's the increase in pressure. So Charles's law states that at a constant pressure, so again, this is staying here, constant pressure, the volume of the gas increases as its temperature increases. So if I have a constant pressure, I'm not changing pressure, and I take this substance, put it on the hot plate, heat it up, those molecules are going to move faster and faster and faster and want to spread out, so its volume is going to increase. It's almost like having a balloon, and if you were to heat it up, that balloon is going to expand until it pops. And the graph, you should know that the graph is what we call directly proportional, meaning it makes a straight line. It's saying as temperature increases, the volume will increase, and it passes through the origin. So pressure and volume, if we were to apply more pressure, these weights represent more and more and more pressure, then we're going to be able to decrease the amount of space this gas takes up. So we're going to be able to make the gas particles occupy a smaller space as the pressure increases. Oops. Boyle's law states that at a constant temperature, so we're not changing temperature this time, if I put more and more and more pressure onto that same volume of, or the same amount of gas, the volume, the amount of space it's going to take up, lessens. That's Boyle's law. And it has a graph that we call inversely proportional, so how it makes this downward slope. And that's it for behavior gases. Hopefully you're able to go back and review this a couple of times in case you're not getting it.